Okay, so it's been a long time since I made an update to the floor-free problem solver thing that I did. But in the last video I mentioned I would include a feature where it would detect that like this corner right here could be was like a false move by the green. So I actually added that. It's pretty easy to do. So I'm just going to quickly show that code. So this is right here. It just checks the basically the corners, yeah, and just it's pretty simple. You can just read through it. Not much explaining to do. It just does what I said, just by checking like the corner and if there's only one possible that can go into it. But then I got around today to doing the group thing that I talked about. So if you don't remember, I think this level has it. So basically, the old version would it would get to this point and then it would get stuck because all the ends have multiple choices. But if we just look at this, we can see that this like dead zone right here can only be occupied by blue, because if yellow went into it or if red went into it, they'd just be stuck in there. They wouldn't be able to get out and they wouldn't be able to join up with the other end. So we know blue's gonna have to go in there. So I figured we should be able to code this somehow. So that's what I spent today doing. So that's what I'm going to go through now. So this is the function right here that's going to do it. It's just added to our solve board function down here, so it's just added in right here. So yeah, that's the advantage of making it really modular and whatnot. So first thing we do, we initialize this array, group array. It's going to be the same size as our board. It's going to take in integers as its data type, and it's going to be initialized as zeros. Now we start x off as 1, and what we're going to do here is basically divide the board. So if we look here, we want to divide the board into two groups in this case, because we have sort of this dead zone that all like links together, and then we've got this dead zone. So there's two groups. For other boards there'll be more though, so we need to account for that. So how we do that is we start with x equals 1 and we say loop over the board, and if you find a 0 then make our group arrays entry at the same place be equal to x, so whatever x is, and then iterate x. So if we just go down here and print out the group array, I've actually got a break further down like a quit, so we won't get the full program running, but we'll see what the output is. I've also added this little line in, but we'll get to that later. So, oops. So yeah, this is the line that I've added in, but like I say, we'll get to that later. So this is what you get out for the group array. So you see we can just get loads of numbers in the place of where the zeros were. So now we need to turn this into two distinct groups, and the way we're going to do that is if we find basically where there's a number and say check your adjacent numbers, and if any of them are so we'll go to 2, if any of them are smaller than you but not 0, because 0 doesn't count, 0 is just like the dead space. So if any of them are smaller than you, then take that number as your own. So we'll delete the 2 and replace it with a 1 because 1's smaller than it. Now we're going to go through the whole grid and keep doing that. So we do it for 4 and we'd say, right, well, this 1 that is now going to be here is smaller than 4, so replace it with 1. Now if I go back to the code, the way we do that is we create an old array, so this is just a copy of what the current array is, and now we're going to have a while true loop. It's going to iterate over the board, it's going to check for basically what I've just said, check that the number next here, so this is the number you are, this is one of the numbers next here, so if this number is smaller than your number and it's not a 0, then we want to change our number to whatever that was. These are encased in tries and excepts because I expect to hit index errors with the reason, like with the -1 and the +1 indexing that we're doing. So we catch all the index errors and we just pass. Should probably print these errors out, but we'll get loads of them. So probably should be writing them like a log file or something, but since I know what these are for, I figured I would just pass these since I was only catching the index errors. Now, once we've looped through the board once, what I'm going to do is I'm just going to print out the group array and then quit here. So this is the board it's looking at. Let's just have a look. See, whoops. So after one iteration through, you see we're getting there, but we're not quite there. We have like this group of 1s, then we've got like a group of 3s, we have a group of 9s, and we've got a random 5 here. So we have one isolated group down here, the 9s, but the rest are all like these 1s and 3s are actually the same group, but it doesn't know that yet. So we need to repeat this process over and over. Now, how many times we have to repeat the process? It'll change with like each board. Like we could just run it like 100 times, but then sometimes you don't need to run it that often. So the way we check how often we're going to run it is using this old array. So we say, is the old array the same as the current array? So numpy.array equal checks this for us. If it is, then we want to break because we know we're done now. Else we want to change the old array to what the new array is and just continue with our loop, so our while true, and just repeat the process again. Now when we're done with all this, when we finally hit that break, you'll see we actually have what we're looking for. So we have all these 1s isolated as group, and then we have these 9s. So far so good, it's working. So next up, we need to know how many groups we've got and what the IDs of the groups are. So if we start an empty list, that's going to be basically telling us what the numbers of each group are. And then we say for number in numpy.unique. So numpy.unique returns a list of all the unique elements in an array. So in our case it'd be 0, 1 and 9. Now we're not interested in the 0, so we loop over this and we say if it's not a 0 then we're interested in it, so append it to our group numbers. Pretty simple. Once we've done that, we iterate over the group numbers and call that the group ID. And then this is mainly this is like the main bulk of what's going to happen now, like the sort of the cleverness to it. So for each group, it has a connected ends list, and it creates a temporary unsolved board. So unsolved board is our our version of the board that is the most solved so far, but still unsolved. So we don't want to tamper with that until we know what we're doing yet. So we'll create a temporary one that we can tamper with. Connected ends is going to be our list of what coloured ends are attached to our groups. Now we scan the board and we say if the point we're at, so if the entry we're at is equal to our group ID, then we try these 4 different cases. So case 1 is what is to the left of it. If it's an end, then append it to our connected ends. And then this bit's important, once we append it, we want to take our temporary unsolved board. So, hold up, let me go back. So, we loop over the group array, for, like this is the array with the numbers in, and we say if that number is the number we're looking for, then check if the temp unsolved board, so this is the one with the letters in, check if the one to the left is an end. If it is, we want to remove it. Well, we want to append it to our connected ends first, then we want to remove it. Now the reason we remove it is if you look at this right here, say we're looking at group 9, so the board looks like this to the machine at the minute, or to the program. Now if we look at group 9, so this group down here, this square, it's connected to the blue end and the yellow end, so it would add them to the list, and it would go to this one, and it would say, right, this is connected to none. Now this one's connected to the yellow end, so it add yellow to the list again, so now it's connected to 2 yellow ends, even though this was actually the same end. So to fix that, what we do is just, when we find an end we're connected to, we just delete that end basically, so we can no longer count it as being connected. So yeah, this basically just loops over and checks like left, right, up and down for connected ends, and deletes the ends accordingly, like as I've just mentioned. Now, once we've done this, you'll see this is what we're left with if I run this. So this is going to run twice because we've got these 2 groups. So you see group 1 is connected to green, yellow, blue, red, red and blue. So it's connected to actually every end, which you can see now it's connected to blue, yellow, yellow, green, green, red, red and blue again, so every single end. But group 9 is the one we're interested in, which is the second one. This is connected to blue, yellow, red and blue again. So you see this is getting it right. Now we need to pull out where we're connected to. So for example, we need to identify in here that we're only connected to 2 ends of the blue colour, and therefore we know that this group needs to be filled with blue. So the way we do this is we start a new list, so colours the 2 ends connected, we're going to call this one, and we loop over the different ends and say if the connected ends count. So count is just a built-in Python function for lists. Just counts how many of a particular entry are in a list. So if there's more than 1 entry of that end in the list, we know it's got 2 ends connected, so we can append it. Then to stop us counting it twice, we remove it from our list because it's already been counted. Once we've done this, we want to check the length of this new list, so the one with only 2 ends connected, and if we only have 1 colour that has 2 ends connected, so we have blue, then we found a colour and must fill that group with the particular colour. So we loop over the array, we check if the position we're at is equal to the correct group ID, so if it's a 9 in our case, we then say if it is, change our unsolved board and fill it with this colour. So this is what the colour is, we just pull it from our list. Once we've finished, so if I print it out right here, so you see once we've done this, we've got the these blues filled in, but if you followed along the previous videos, you'll know we need these to be capitalised for it to count, because at the minute it thinks all these are ends. So now because we've filled it, we've actually connected 2 ends, we know that these can all be capitalised because we know now that colour, that particular colour is complete. So really simple, we just loop over the array again. Right here, there's a lot of looping over the array, but this is the final time we do it. So we loop over the array and we say if the particular element we're at is equal to the colour that we're looking for, then capitalise it, and then once we've done that we return the unsolved board. I can just print it out finally down here if you want. So there we go, it gets the blues all capitalised. Now obviously the board still isn't solved, but now we can look back into our other methods. So once we get to this stage, which it's now at, it should be able to figure out that yellow has to go up here, and then because that green has to come out, and then like from there on it can solve it. So yeah, that's basically the next algorithm implemented. What I might do now is just show some of it running on levels that couldn't be solved. So for example this one, the question it asks you when you run the code is so ask you, do you want to quit when we hit a level we can't solve? So if you've seen the previous videos, you know when it finds a level it can't solve, it actually just skips the level and goes to the next one. So I've put an option in here where it'll either skip or it'll just quit the script. So if it chooses to quit the script, then we get to see where it got stuck and how and stuff. So I'm going to choose to quit because I want to show the next step. So level 16 right here is one that couldn't be solved with the old methods, and you see now it has no problem. Now using this, I've actually run it through every level and it's managed to solve I think 17 more levels since the previous version. So it's an improvement, but it's not amazing. Now this is where it gets stuck, so this is the only 5x5 it can't solve. And I think this is where I'm going to have to start adding in like some sort of guesswork, because I can't think of any forced moves here. If you can think of any, feel free to let me know, but I can't think of any forced moves here that we can implement. So what I'm thinking of doing is adding some sort of thing to check, like if you're on the edge, to just go around the edge, because that's generally a good move. So for example, blue just goes around here, then out to here, out to here, then green's forced, and red is forced, and basically the whole level gets solved. So that obviously has potential mistakes, but if this is used as like a last resort, then at least it's going to help. It can't really make it any worse, because if it doesn't solve it, then it doesn't solve it. It's not solving it as is, so it may as well try. As for any other features, it still just prints out the best solution once it finds so down here, like solution was not found, best solution was, and tells you where it was at. So like this is how I know that it got to here. You can just read this grid. It's really useful for like figuring out new methods and stuff. So yeah, I think that's about it. Doesn't have anything new in here, I don't think, other than this mode that I've just mentioned, the input. So yeah, next up I'll implement the going around the edge, and other than that the code's going to be on GitHub now, and there'll be a link in the description below, so if you want to check it out yourself and maybe run this and maybe help out coding it, if you've got any ideas of algorithms to add or whatever, or you just want to play about with it, then feel free to go check it out. It does run on the time trial stuff, so you can try it yourself. You can run it like on here. Whoops, I'm not showing you. On here. So we say no, you don't want to quit when you can't solve a level, and it'll just go through indefinitely trying to solve the time trials. I think its record so far is like 9 or something in 30 seconds. It could probably improve, like there's some time.sleeps I have just to control it in like the normal mode, not the time trial mode. But yeah, you could take that out and probably get some speed improvements. But yeah, that's it for this video, so feel free to check out the GitHub down below. If you like the video, like it, feel free to subscribe, all that good stuff. So yeah, thanks for watching, and I'll see you in the next one.